Now, this question is from the chapter of electric charges and fields. And as you can see, there are multiple charges, and the question involves the calculation of force. Okay. When you see charges which are stationary, electrostatic, and you are asked questions on forces, these are pertaining to Coulomb's law. Okay. That these questions talk about the charges being on the x-axis and y-axis, okay, which means there is a sense of direction. So the point is, even if you understand Coulomb's law very well, what probably most of the students don't understand is vectors. Your vectors have to be very strong in class 12th. If you understand vectors, this chapter is a cakewalk. Now, let's see the diagram number 1. There are two charges which are Q2 and Q3. Okay, and these two charges are, you can see their location is given to you, and they exert a net force on Q1. Okay, this is your Q1. Now, let's see how this, so both the charges are positive, and the charge number Q, which is fixed, right, is unknown what exactly is happening, but it says that the net force is in the x direction, which means positive x direction, which means, all right, so let me just quickly draw the vector representation of this question and show you the respective. So this is your y-axis, this is your x-axis. There is a charge here which is, look at it, Q1, this is Q3, and this is Q2. So if with the help of a knowledge of vectors, what I'm doing is I will draw a vector. So the problem is we don't know the sign of Q1. Is it positive, negative? Let me treat this as a positive charge. So let me just draw this line which shows repulsion. Okay, so this is repulsion, and so Q1 is lying here. Let me show. So since this is also positive, this is positive, and I'm assuming Q1 also to be positive, I will draw one more line which is going to be a repulsion line. So let this be repulsion line. All I'm doing now is Coulomb's law in vector format, right? This is also a repelling line. So, and if you resolve the vector which I've just drawn, getting the vector, repulsion vector in x and y component, you should know how to do that resolution, right? So this is the force on Q1 due to Q2, and this is force on Q1 due to Q3. Let me just split this vector also. So I'm just splitting the Q2, Q3 vector. Okay, and I draw this, right? If you notice, the y components are getting cancelled. These are the y components which are getting cancelled, and x components are getting added. But the direction which is coming is negative x-axis, right? This is, but in the question, the direction which is given is positive x-axis. So this means our assumption that Q1 is a positive charge is wrong, right? So let's draw the second situation and see if we take Q1 to be negative, what happens when we apply vector form of Coulomb's law, whether the net resultant force on Q1 is now in positive x-axis or not. That's a mystery we need to solve now. If I draw this, the force which is being experienced by Q1 due to Q2, right, is attractive, for example, right? Now I'm taking another reverse example. I'm trying to guess the sign of Q1, which is unknown, but the direction of force is known. Okay, if I resolve this vector, which is the force on Q1 due to Q2. There are two vectors associated with it. One is this, the other is this, right? And if I calculate the force on Q3 on Q1 due to Q3, this is also attractive. If I draw the vectors, this is 1, this is the vector and the x component. If you notice, the the way this is working out, sorry, that this direction is not correct, right? So this is the x component, this is a y component. You can see the y components cancel each other. The x components are getting added, and this proves that the Q1 charge is a negative charge, right? It is experiencing attractive force from Q2 and Q3 respectively. The question is definitely, we didn't know the sign of the Q1 charge, right? The sign of Q1 charge is known. It is 100% negative now. And we guessed it using the concept of vectors. Vector algebra added up to show that the net force is in the positive x-axis direction, and therefore made sense that this charge is negative. Positive charge Q is added somewhere on the x0, right? So you're adding charge. Now I'm referring to diagram number B, and you're adding a charge Q on x comma, and now question is, due to addition of this charge, okay, and this is also a positive charge, so charge is added, positive charge is added, which I'm showing now. So this is the positive charge which has got introduced. Q1 is experiencing force in positive x-axis, right? So if you introduce a positive charge, what will happen? Due to this positive charge Q, the attraction on Q1 will increase, right? Because they're opposite in nature. We have established Q1 as a negative charge. We've already done this exercise, and Q is positive. So what will happen? The force experienced by the Q1 charge will go up towards the positive x-axis. So our answer is Q1 will experience a further attractive force towards the positive x-axis due to introduction of the positive charge Q. This is the way we need to approach. So you can see this anyway was towards positive x-axis. Q, the new Q will attract it further. So the resultant force will increase in the positive x-axis due to introduction of positive Q. So I hope you could appreciate that the question is mainly focused on knowledge of vectors, and with the help of vector we were able to establish the sign of Q1, and that really helped us solve this problem. So thank you very much for your time, and wait for my next video.